Hello, as you can see in this question, it is asked a ball is released from rest above a horizontal surface. The graph shows the variation with time velocity. So the ball is dropped like this and it hits the surface. So the velocity is increasing while falling. Just before hitting the surface, the velocity is at peak, and after this point, the velocity becomes zero when it touches the ground. And now it is um so it comes to zero, and now velocity will be in the opposite direction. This part shows that the velocity will be in opposite direction now. And the magnitude of the velocity, as you can see, has decreased a bit. Now it will go up for a while, up for a while. Okay, let me draw it correctly. So it falls to the ground while just before touching the ground, it is having highest velocity. Well, when it touches the ground, it comes to zero, and then the direction of the velocity changes to opposite, and it will move up again. And after this point, again the ball has zero velocity, and after this point, it will again come back to it will become greater while falling down. Again, the same thing repeats here. So when it touches the ground, becomes zero for just a very brief moment of time, and again the velocity is the direction of the velocity changes to opposite, and again it reaches a peak point where the velocity is zero, and again it falls down like this. So from this graph we can figure out this is what is happening. Now let us go through the options to find out which among these is correct. The ball's acceleration is the same during upward and downward motion. So we can say ball is accelerating. That means accelerating with g plus g while going down. But while going up, it is actually the g becomes negative. Why? Because it is opposite to the positive g. That means it is going upwards. That's why it becomes minus. And again, while falling, it becomes plus here. And again, while going up, it becomes minus. Again, what going down, it becomes plus. So we know magnitude of g is 10 meters per second square. So magnitude will remain same. That is for sure. But the sign is changing from plus to minus. While falling down, it is plus. While going up, it is minus. Again, falling down, plus, minus. While going up, and again plus. So we cannot say, we can say that this option is not correct. Since the symbol is changing, that means the sign is changing. That means the acceleration is not same while going upward or downward. Okay. Second is the speed at which the ball leaves the surface after an impact is equal to the speed at which it returns to the surface for the next impact. As you can see, it is not same. Velocity is not same. Here the velocity is highest. Here the velocity is decreased a bit. Here it is totally decreased. Okay. So velocity does not remain same in these three impacts. So this is also wrong. C, for an one impact, the speed at which ball hits the surface equals to the speed at which it leaves the surface. For one impact, the speed at which ball hits the surface equal to the speed at which it leaves the surface. Okay, since you can see when it hits the surface, it is having highest velocity, and after leaving the surface, it does not have that magnitude here. It does not have this magnitude. Here, as you can see, this is high. This is velocity is high. Here, the velocity is comparatively low. So this is also wrong option or incorrect option. Now we are left out with D. That is, the ball rises and falls through the same distance between impact. Okay, ball while rising, as you can see, ball while rising, the covered distance is this much, and while falling also the covered distance is same. Here in this case also, while rising, it has crossed this distance, and again while falling, it is falling by same distance. So option number D is the correct answer. Thank you.